Basic Proportionality Theorem. It's also known as Thales Theorem. It says that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Now, although we practically saw this, let us try to prove it theoretically, mathematically. So what is given to us is a triangle ABC in which DE is parallel to BC, D is a point on AB and E is a point on AC. We need to prove that AD upon DB is equal to AE upon EC. Let us do one thing. Let us do a little construction. We'll join BE and we'll join DC, and now we'll draw DM perpendicular to AC. One more perpendicular which will be EN just perpendicular to AB. Now let's start with the proof. First of all, if we need to find the area of ADE, let's write it down, area of AD. Let's do one thing. Let's bring this triangle down for convenience. And now we have spinned it. So this side AD is over here. This is the point E and this is the point N. Now we know that area of a triangle is given by half into base into height. So if AD is the base, EN is the height, right? Similarly, now we'll find the area of triangle BDE. Now this is obtuse triangle. Angle D is greater than 90. Let's do one thing. Let's bring it down along with this altitude. In an obtuse triangle, the altitude lies outside it, right? So this is the side BD, this is E and this is N. So its area will be given by half into BD into EN, correct? Now, we do have two equations. We are going to divide them. So this will be area of triangle ADE divided by area of triangle BDE equal to this. Half and half will cancel out, EN will cancel out, so it gives us AD upon BD. Now think about this. If in this triangle ADE, if we take AE as the base, then the height is DM. So area of ADE can also be given by half into AE into DM. That's the base and that's the height. Now if we find the area of triangle DCE, EC is the base, its height lies outside, the altitude lies outside, which is DM. So this is half into EC into DM. Once again, we'll divide these two equations and we get this. DM cancels out, half cancels out, we get AE upon CE. Let us write this equation and this equation on a cleaner page over here. Now, we have two equations. Let's call them equation 1 and 2. In both of these, on the left hand side, the numerator is same. The denominator is area of BDE. In this case, it's area of DCE. That is this triangle and this triangle. Actually, the area of both of these triangles is equal. And that is because BDE triangle and DCE triangle lie on the same base DE and between same parallel lines DE and BC. If we have two triangles which lie on the same base and between same parallel lines, their areas are equal. Let us call this equation 3. Now from 1, 2 and 3 we observe that the numerator in 1 and 2 are same. The denominators are equal again. So the left hand side of both of these equations is equal. That means the right hand side is also equal. Therefore, AD upon BD is equal to AE upon EC. And that is what we wanted to prove.